Hi everyone. I just wanted to help you guys out a little bit with today's Delta Math. Some of you have reached out to me and said you were having a little bit of difficulty with the assignment. So I'm just going to open up a question or two and work my way through them, and hopefully this will help those of you that are having some trouble. So the first part of this assignment is questions about determining the features of a rational graph. So you're going to be given a function and you're asked about all the different types of discontinuity as well as the x and y intercepts. So the first thing, also I just emailed all of you letting you know Miss Hume made a really great, clear toolkit. And I'm going to just open it up here for you. So this is posted on Canvas. I also sent it in the message for you guys to view. So what it's telling you in this toolkit is that you need to look at the function in factored form. A pod exists if you can cancel out a factor from the numerator to denominator. To get the y value in a pod, you would then use that simplified version of your function and think about the limit as x approaches that value in the pod. What is y? What is the function approaching? And then that is your actual point of discontinuity, the x value and the y value together in that point. The vertical asymptote is basically any other value that makes the function undefined that wouldn't be the pod. So anything left in the denominator after you would simplify your fraction, any values that make your denominator 0 are going to be now vertical asymptotes. Horizontal asymptote is what you're going to be thinking about when we looked at the limits as x approached positive and negative infinity, and we talked about n behavior models. That is how you approach a horizontal asymptote. So if I look at, again, the example in the toolkit, if I take a look at the highest power term, which is 4x squared in the numerator, and the highest power term in the denominator, 3x squared, I look at that simplified fraction now, and because they're the same power, both raised to the second degree, that would simplify to just be 4 over 3. So that is the horizontal asymptote for this function. If I'm asking for an x-intercept, you set the function equal to 0, which means you're making y 0, and you solve for x. If you do get a value like we did here that is either a vertical asymptote or in the pod, then you would need to reject that as being an x-intercept because it's a point of discontinuity or it's discontinuous there. And then for a y-intercept, that's when x is 0. So you'd be plugging in a value of 0 into the function for x and seeing what you get for your y values. It is possible to not have x-intercepts and to not have y-intercepts. Okay, so now let's go back to delta math. So this just happens to be the function I was given first. There is nothing to factor in this function, which also means that there is not going to be a hole since I am not able to cancel out any part of this function. So now I'm looking at the denominator and I can see here that this value of 2x, if x equals 0, that's going to make my function undefined. So I do have a vertical asymptote of x equals 0. Since I can't then plug 0 into this function for x, that's going to tell me I have no y-intercept. Okay, and then as far as a horizontal asymptote goes, if you look at your highest power term in the numerator is x to the first, and in the denominator it's also 2x to the first. So let me just come back to the toolkit for a moment. So we have x minus 5 over 2x. I'm just going to write that down here. Sorry, add a page just so I can write for a minute. Okay, so if we have this as our function, x minus 5 over 2x, I'm thinking about, okay, if I took the limit as x approaches infinity of this function, I would be just looking at the highest power term in the top and the highest power term in the denominator, which really is just going to be 1 over 2, since the x's would simplify to just be the coefficient. So this y equals 1/2 is going to be my horizontal asymptote. I'll just put 0.5. And as far as x-intercepts go, I'm going to come back here a minute. If I now take this function and set it equal to 0, so when y is 0, what is x? We get x minus 5 is equal to 0, x is equal to 5. Okay, so now we'll submit. All right. And the nice thing about Delta Math, I know it's frustrating when you get, one part wrong and it makes the whole question wrong, and I'm asking you to do 10 of them, but they're very detailed in their explanation. So please, when you get something wrong, definitely scroll through their answer and look at their solution and look at their suggestions, because it is going to correct it for you and hopefully allow you to get it right the next time. Okay, I hope this was helpful. I will definitely be willing to do this again. If you're ever having trouble, please reach out to me, because if you let me know your concerns, I can try my best to either make a video or, like Ms. Hume did, make some type of toolkit and post things for you guys so that it's more helpful. And someone did suggest, can we have some worksheets? Just know that I'm working on that. I think we're going to have a worksheet posted for tomorrow and for Monday. So we won't always be using Delta Math, but we'll go back and forth. Okay, I hope everyone is doing well,